What if a single loose bolt, just a tiny piece of metal drifting aimlessly in space, could trigger a chain reaction capable of destroying hundreds, even thousands, of satellites? This isn't a scene from a science fiction movie. This is a very real scenario that space agencies around the world fear the most. This is the shocking and frankly terrifying story of how one tiny, seemingly insignificant object led to a massive, cascading disaster high above our planet. Space might seem vast, empty, and infinite, but the region just above our heads, Earth's orbit, is becoming dangerously crowded. Right now, thousands of active satellites, countless spent rocket stages, and millions of tiny fragments of debris are circling our planet at mind-boggling speeds, over 17,000 miles per hour, or 27,000 kilometers per hour. At those velocities, even something as small as a fleck of paint can hit with the force of a hand grenade. A small bolt, it becomes a deadly, untrackable projectile. Today, we're going to follow the journey of one such loose bolt and witness how it set off a catastrophic chain reaction that threatened our modern way of life. Our story begins during a routine maintenance operation on a commercial communications satellite. An astronaut performing an extravehicular activity is making a standard repair. In the silent, weightless environment of space, a small, high-tensile bolt accidentally comes loose from its housing. It doesn't fly off violently. It just gently floats away, slowly tumbling end over end into the blackness of orbit. Normally, objects of this size, once they become separated, are tracked by a global network of ground-based radars. They're given a catalog number, and their orbits are predicted. But this bolt was just slightly too small, just below the threshold of what our current systems can reliably detect. It became a ghost, a phantom object silently circling the Earth every 90 minutes. Its path, a ticking clock, waiting for the inevitable. Several months pass. The bolt continues its silent journey, its orbit slowly decaying and shifting due to minute gravitational pulls and atmospheric drag. Then, its trajectory intersects with a state-of-the-art $300 million commercial communications satellite, a vital hub for global internet and television signals. The impact is instantaneous and catastrophic. Traveling at orbital speed, the kinetic energy released is immense. It's not just a puncture, it's an explosion. The bolt rips through the satellite's critical systems, tearing apart its solar panels, fuel tanks, and electronics. In a fraction of a second, the once pristine satellite is shattered into hundreds of pieces of jagged metal and plastic. These fragments, now a lethal cloud of shrapnel, don't just fall back to Earth. They are blasted outwards, scattering across a wide range of similar orbital paths, creating a brand new and much larger field of deadly debris. This debris cloud didn't just dissipate. Within hours, the nightmare began to unfold. Some of the larger fragments from the destroyed satellite slammed into another one, a weather satellite crucial for forecasting. This second collision created even more debris. This cascading runaway effect has a name, the Kessler Syndrome. It's a scenario first proposed by NASA scientist Donald J. Kessler in 1978. He theorized that once the density of objects in low Earth orbit reaches a certain critical point, a single collision could set off a chain reaction where each impact generates more debris, which in turn increases the probability of further impacts. It's an exponential growth of destruction. Suddenly, what was one loose bolt had become thousands of new, untracked objects, all racing through the most valuable orbital highways, threatening GPS navigation satellites, Earth observation platforms, and even the International Space Station, forcing astronauts to take shelter in their escape capsules. Down on the ground, the effects began to ripple across the globe. Mission control centers started receiving a flood of malfunction alerts and loss of signal, warnings from multiple satellites. Global communication networks, which rely on these orbital relays, experienced widespread disruptions. Internet blackouts, dropped international calls, and scrambled television broadcasts became common. GPS systems, the backbone of modern logistics, aviation, and even our car navigation began experiencing critical glitches, leading to chaos in shipping and transportation. Several high-profile rocket launches, including missions to resupply the ISS and deploy new scientific instruments, were indefinitely delayed or outright canceled. The risk of flying a billion-dollar rocket through these newly formed dense debris fields was simply too high. What started with a single, lost bolt had now escalated into a full-blown global space crisis, demonstrating just how dependent our modern world is on the fragile infrastructure we've built in orbit. The global space community was forced into emergency response mode. Space agencies and private companies scrambled to track the new debris clouds and reroute their most valuable satellites to safer orbits, a process that consumes precious fuel and shortens the operational life of the satellites. This incident became a stark, sobering case study, a wake-up call that showed just how fragile our orbital environment truly is. New, far more aggressive cleanup missions were proposed, from robotic arms that can capture debris to giant nets and even space-based lasers designed to deorbit dangerous objects. Stricter international guidelines for satellite construction, deployment, and end-of-life disposal were rapidly drafted and enforced. It was a hard-learned lesson, demonstrating that in the interconnected system of space, one tiny object, one moment of carelessness, could unleash utter chaos. Space debris isn't just some distant, abstract problem for scientists and astronauts to worry about. It's a growing and direct threat to our connected, modern world. The technologies we rely on every single day are at risk. If you found this story fascinating and want to learn more, please hit that like button, subscribe to the channel, and share this video to help raise awareness about the dangers orbiting just above us. This is Cosmic Collision Profiles, where we uncover the hidden dangers of space. Thanks for watching, and we'll see you in the next one.